We will write a Python script that will select all square from the input image using OpenCV. We will do this by highlighting each square present in the image. This will be the input image, and after processing it with Python script using OpenCV, this is now the output image. As you can see, all the squares were selected using a green solid line. So to begin writing our algorithm, let's now open our VS Code. I have now opened my VS Code. So the next move that we will do is to create a new file, and we will name this file demo.py. And then we have to import the OpenCV. Let's write here import cv2. And then let's load the image. Let's write here img cv2.imread, and then specify the file name where it is located. The file that I'm going to use is located inside of an img folder. And then the file name is 4.jpg. And then we have to apply a smoothing technique so that we'll be able to reduce the noise of the image. And the technique suitable for our case is the bilateral filter, because while it smoothens the image, it preserves the details of the image. So let's write here BF for bilateral filter, and then CV2 bilateral image filter, and then the image that we want to filter, and then the size of the neighbors affected by the filter, and then 100 by 100. So you can play around with these arguments and see for yourself the effect of those numbers that you choose. And once you find the suitable numbers, then stick with that. And on my case, I used 20, 100, 100. And then after that, I'm going to create a grayscale image. So the grayscale image will serve as the basis for getting the threshold. So the threshold will be a binary image. So for now, let's just create a grayscale image. And for that to happen, let's convert our image into a grayscale image. All right, so after having the grayscale, let's now get the threshold of this image. So the threshold will enable us to create binary image, and that binary image will enable us to create the contour that contains the continuous curves. So let's start getting the binary image by using the threshold. And since OpenCV has a method of what we call the threshold, we will make use of that. So let's write here threshold, and then let's type here the grayscale image together with the threshold value. And then if the value of the pixel is greater than the threshold, and then it will return 255. And then the approximation method, we will say it here that there will be no approximation method. So let's write cv2 dot chain approx none. And then the threshold method usually returns a tuple. And from that tuple, we are only interested on the threshold value. So let's write here the return value and the threshold value. So we are only interested on the threshold value, which is in this case is the th. And then after this, let's figure out how to find the contours out of the threshold. And since OpenCV has a method called find contours, we will use that method. So let's write here find contours, and then let's specify here the threshold, and then we want to get all the contours, so that is why we will set the mode to return all the contours by using the ret r3, and then with no approximation. And since again this find contours method returns a tuple, we have to supply two variables, contours and hierarchy. And we are only interested on the value that the contours variable has. And then for each contour that we can find inside of contours, we are going to get those curves inside of each contour. So for that to happen, let's iterate for each contour inside of contours. So for C in contours, I'm going to get the curves and store it on the approx variable by using the CV2 approx polydp. And then we will supply here the contour, and then I'm going to write here 0.01, and then we have to get the measurement of the perimeter of the curve. And for us to get that, we have to use the arc length and supply also the contour here. And we are only interested on those curves that are close, so we have to write here true, as well as on the approx polydp. We are only interested to those curves that are closed. So let's write here true. So meaning it will only get those curves that are closed. Okay, so we multiply the perimeter of the curve by using the arc length with 0.01. So why did I choose 0.01? Basically, I've choose some random numbers and I find 0.01 is suitable for my case. So you can experiment on this, and whichever is convenient in your case, then stick with that number. And then I have to examine if the curve has four sides. So to do that, I'm going to use if here and then examine the approx variable if it contains four sides. So if it contains four sides, then it means it is a rectangle or square. And then let's draw here a line to those curves with four sides. So let's write draw contours on the image using the curves from the approx with the following colors. The blue is 0, the green is 255, and the red is 0. And the thickness is 5. Then after that, we will save the file. So let's write here cv2.imwrite, then specify the file name of the image. So let's write here img4.processed.jpg, and then the source image. All right, so let's try running this script. So we have an error at line 13. So it says here that contour IDX is required to be an integer. So we forgot to include the contour IDX. So for contour IDX, we have to supply here 0 because we want to draw all the contours that we have on our approx variable. So this is why it is suitable to write here 0 instead of other numbers. So again, let's try running this script. Okay, and then let's see the result. This is the input image, and then this is the output image. And as you can see, all the boxes were highlighted. So that's the end of this video, and thank you for watching.